Hello, this is Michael Sulak, and the purpose of this video is to look at some angles and connections between measuring angles in degrees and measuring them in radians. Here's a diagram of a circle. There are numbers going around the circle. All of these numbers are measuring angles, and they're measuring them in a unit known as a degree. And the degree measurements are all regarding a position where the angle will start in this location and then end in one of these lines here. For example, this angle right here is a 30-degree angle. That pattern continues where you're seeing, quite a few angles here and their measurements. There's kind of some famous ones. 90-degree angle is a component of a right triangle. That's when two lines meet in a perpendicular fashion. So a lot of times we write a 90-degree angle with a little square in the corner of that angle. Other important angles, well, they're all important. But you see a lot of patterns. Here's 180 degrees. That would be a straight line. A little interesting to think of that as being an angle, but you can. If you keep going, you get angles that are large. Here's a 330-degree angle. And then if you go 30 more degrees, you're at 360 degrees, which brings you back to where you started. So that position, it's just as valid to call that 360 degrees that make up one complete revolution of a circle. This is all measuring angles in degrees. Generally, you have a decent amount of experience thinking in degrees. You think about angles as being a 90-degree angle, 360 in a circle. An important concept when it comes to trigonometry is another way to describe the size of an angle, known as a radian. Here we have a bunch of angles in radian measurements. For example, just to remind you what's happening here, here's an angle, and the measurement of this angle is pi over 4 radians. I think it's a little unfortunate that there's not a symbol for radians like there is for degrees. If you're measuring 30 degrees, you see a little circle up here. For radians, somebody might write radian, or they might just give you a number. You have to pay a little bit of attention when you're talking about the size of an angle and whether or not that's in radians or degrees. A radian is a way to measure the size of an angle. And what is a radian exactly? So a radian is a unit of angle measurement, just like a degree. A measurement that is totally related to the radius of a circle. So the radius of a circle is a distance. So the radius, they're very similar sounding words, radius and radian. The definition of a radian is that if you take an arc on the outside of the circle equal to 1 radius. So here is an arc. So let's just say that arc has a distance of 1 radius, then that angle that's created, which is not shown on this circle. This circle is showing 30-degree angle here and a 45-degree angle here and a 60-degree angle here. So that angle that's created, I'll label this angle here. We love calling angles theta. When you have this angle here, theta, that is created by an arc length equal to the radius, you can say the size of theta is 1 radian. And that's always the same. Just like a degree is always the same. 1 degree is a very small angle. 1 radian turns out to be about 57 degrees. So you could also say the size of this angle theta is about 57 degrees. What's really, really nice about radians is that they make all sorts of calculations kind of cleaner and nicer. Take this circle, for example. I've shown 1 radian here, so that's about 57 degrees. So that would mean that 2 radians is about 114 degrees. So if I wanted to locate another radian distance on this circle, I need to go to 114 degrees. So the perpendicular line is 90 degrees. I need to go 24 more degrees than that. This little slice of the circle is 30 degrees. It's about 6 degrees less than that. I'm right about here, say. Again, this is not perfect, but I think it's okay to realize that you don't have to be perfect. Right here, the distance of the entire angle created, that angle is 2 radians in size. And then so if I went another radian, I would be at 3 radians, and you're at 171 degrees. That's about 9 degrees less than here. So here's another radian, 3 radians here, and you'll see that it's not quite half the circle. It's a little less. So here's a question, is how many radians is half the circle? We have to go a little bit more than 3 radians, and it turns out, I think this is just so interesting. The number of radians in half the circle is pi. Good old pi, which is about 3.14159. Pi is an irrational number. There are exactly pi radians in half of a circle, which is a very nice result and makes all sorts of things cleaner when you're measuring angles in radians. So you kind of want to train yourself to be able to think about radians in the same way that you think about degrees. So let's erase these angles here. Well, maybe I'll draw the angle that is pi radians. Let's call it alpha down here. So alpha, and it equals 180 degrees, but it also, the size of it is pi radians. That's a really, really, really important result. If you can remember that half a circle is pi radians, that gives you all sorts of good things. So then let's just look at a few more important angles. So what about if I'm talking about now this 90-degree angle here? That's half of pi. Pi is the half the circle, so that 90-degree angle is half of pi. If I look at the measurement on the circle that I had shown you earlier, 1/4 of the circle is pi over 2 radians. So again, this is talking about this angle here. What if we take half of that angle? This angle here, how big is that? That's going to be this pi over 2, and we need half of that. So that's pi over 4, the halfway of 90 degrees. The 45-degree angle is pi over 4 radians. There's just so many patterns here with these angle measurements in radians. So half the circle is pi radians, and if you go around the entire circle in radians, you get 2 pi radians because it's twice pi. Pi is 1/2 the circle, 2 pi is the entire circle. So 360 degrees is 2 pi radians. How about this angle right here? I can tell you that that's 30 degrees. There's so many patterns here, but why is that 30 degrees? It turns out that if you look at this angle measurement here, which is 90, if I call this angle, maybe I'll call this angle beta. So there's 1 beta, here's 2 betas, here's 3 betas. This angle right here, it's splitting 90 degrees into 3 parts. So you know that the angle measurement of any of these betas here, because they're all the same, is 30 degrees. What is that in radians? Well, you could find it in a lot of ways. I'm going to do it what I think is the easiest way. So there's 3 betas in 1/4 of the circle. There's going to be 3 more betas in the other quarter of the circle. So in half the circle, there's 6 betas. Basically what I'm saying is that this angle is splitting half the circle up into 6 equal parts. And so in terms of radians, if there are pi radians in half the circle, and we take that angle and we find 1/6 of the angle of pi radians. And so that means that beta is just 1/6 of pi over 6. That's why this angle here is pi over 6 radians. We've got pi over 6 here. That's the first smallest angle coming off the standard position. We have pi over 4. Another way to think of pi over 4 is it's taking pi and splitting it up into 4 pieces, 4 angles that each have a measurement that's the same. They're pi over 4. For this angle, we have one of them. So the last angle that I'm going to look at is the third one here, this one. You'll just notice that this angle, well, it does a couple of things. This angle splits up half the circle into 3 parts. Here's one of them, here's the other, and then here's the other. So I do think maybe this is the simplest way to think about the measurement of this angle. It's taking the pi, that's the entire half circle, and it's divided into 3. If I call this angle theta, then it's 1/3 of 180 degrees. Theta is 60 degrees. Let's get that in radians. Well, there's pi radians in half the circle, and we're 1/3 of the way around. This is pi over 3 radians. That's where these measurements come from. This is 1/6 of half the circle, so it's pi over 6. This is 1/4 of half the circle, it's pi over 4. This angle is 1/3 of half the circle, it's pi over 3. This angle is half of half the circle, it's pi over 2. Here's the whole half the circle, that's pi. And then if you go the whole way around the circle, you have 2 halves, you have 2 pi radians. 2 pi radians is the same thing as 360 degrees. And if you understand these really well, the rest of it, you can figure it out with some knowledge of how fractions work. I'm just going to leave the video here. I'm not going to show you all those numbers. There's a lot of numbers on this circle. If you understand these 4 angles, you're very well on your way to feeling confident about using radians as an angle measurement, just like you can use degrees as an angle measurement. I hope that made some sense, and I wish you luck with whatever you're undertaking. This is Michael Sulak, and I will see you next time.